Hi, welcome to ITech 136, Principles of Programming. We are studying function and you're going to find a lot of problem when you write function. And these are some of the common problems or mistakes that students have made. And first about the tips. And the tips center around the function parameter. Use the function parameters to pass data to a function. And just remember this. Function gets its data from the function parameter. So you do not need to prompt user for input in the function unless that is the sole purpose of the function getting user input. Do not override the function parameters values unless you know what you're doing. And do not use the global variables unless it is stated okay to use. And also, use the return statement to return one value. And please do not use the print statement to display the return value. You may see the output on the screen, but there's no data is returned. So these are the common error. Copy and paste code among function, but they're not complete all the necessary modification to the pasted code. You have seen me maybe copy and paste the code and then make some smaller changes. Make sure you make all the necessary change. Return the wrong value. Well, you can write function with many variables in the function. And I always said that make sure you understand what data are stored in each of the variable and what data need to be returned. And fail to return value for a function. Again, don't use a print to show the return value. The caller does not see it. Did not use a function parameter. So let's look at each of these scenarios. The function on the right is a correct function. I have a myfunc1 which takes two parameters and then I just return the sum of the two numbers. So if I run this program, then I have that prepared. If I run this, given 101, num1 is 101, num2 is 136, I add those two numbers together, I got 237. That look good. What happened, instead of return, I changed to print. So let's run that. You still see 237 on the screen. However, do you see the sum of 101 and 136 is none? You do not get the value. What happening is this myfunc2 does not return the value. As a result, by default, it returns none. If you have no return value, the function returns none, N-O-N-E. So result is none, not 237. This is probably by far one of the most common error I see. Another error I see is prompting user for input. Function get its data from the function parameter. When you call the function, you pass the data. You pass the data when you call the function. That's how function gets the data. You don't need to prompt. So what happens when you prompt inside the function? Well, the program going to run, and let me show you. The program going to run, and maybe I just say 10 and 20. The sum of 101 and 136 is 30. I call the function and I pass a parameter 101 and 136. Inside the function, you prompt for the number again. And I just happen to enter a different number. And then you do not get the right result. And then I say, oh, then my student said, oh, I don't, so let me make that not to pass the parameter. So that function can prompt for input. Well, yes, you can do that. And yes, you might see look like it's working. So if I run this program, parameter 1, I take 10 and 20. But if your intention is try to get you do the 101 and 136, that means either you had to answer this of 101 or 136, but then you have defeated the whole purpose of function parameter. Imagine, just imagine, this function being called 1,000 times. Every time you do prompt, it's gonna stop. Maybe I want to add two different number, 1,000 times from coming up from the database. I get some number off the database and I want to add those two number up. I get 1,000 of number. Well, that's not going to work if you keep prompting. That defeats the whole purpose of the function. Another pitfall is you change the parameter. I pass you 101 and 136. Instead of prompting, you override the parameter. Yes, you can do that. And yes, it will run. So if I run this program, sum of 101 and 136 is 30. You override the parameter inside the function. Then you do not return the expected result. You can do that. If you know what you're doing, you could do that, but I would suggest not to do that. Do not override the parameters, at least in the beginning, until you understand better how the function and all the variables work. And another thing is testing the function. You have to understand how the function should work in order to test it. So given the input, what is the expected output? And what is your program actual output? Latter testing is one of the most common problems with the student writing a function. They see some output and they thought the output is correct and they're done. So you need to generate some test cases. So let's do a very simple problem. Write a function called add to num1 and num2, which takes two integer number. The function returns the sum of the num1 and num2. So that looks very simple. I just add in two number. Let me see. Add to num. So let me call this add to num. So write a function called add to num1, num2. I'm going to make a mistake. Instead of adding, I mistype. I do multiply. And then you are testing that. And you have one simple test case. So maybe let's say sum of 2 and 2 is. And when you run this, you're going to see sum of 2 and 2 is 4. Hey, that's correct. Even though you make a mistake here, you have one simple test case. You see a correct answer and you thought it's correct. What happens if you make another test case? Say for example, sum of say maybe 3 and 3 is. And you run this. Sum of 2 and 2 is 4. Sum of 3 and 3 is 9. Is that correct? Sum of 3 and 3 is 9. Is that correct? If you run more test cases, you can see what you're expecting is 6, but you got a 9. That means your function is wrong. Something is wrong with the function. And then you need to debug what's wrong. And based on these results, you can see, instead of adding, look like I did multiply. So when you check that, I make a mistake, and you correct that, and you rerun the test, and then you see some correct result. Your expected, this is the actual output, which is same as what you expected, so your function is working. And I would say this, You should have at least 3 test cases. More the better. You should test the expected corner and the corner cases and even illegal input to see what happens. And these are some of the most common pitfalls. And so, and another problem that I see, especially when you work on the Zybook lab and the channel activity, program activity, is white space and the precise formatting. White space is any blank space, tab, or new line. So most coding activities strictly require student program to match exactly the expected output, including the white space. I hear a lot of complaint. My output is correct, but Zybook say mark it incorrect. It marked incorrect because your output does not look like what they're expecting. So correctness often includes output being formatted correctly. And how do you do that? You can do that with pay attention to the output. So let's do another programming, right? Program must be created precisely to run correctly. Everybody know what the equal mean assignment. The double equal mean equality. They are different meaning. Using I and J, using I where J is meant can yield hard to find bug. That's why I said always use a meaningful variable name. Don't try using IJ and K. Using some meaningful name. Not considering n could be 0 or in sum divided by n. If n is 0, you will get an error. You cannot divide number by 0. Counting from I being 0 to I less than 10 versus I less than equal to 10 can mean difference between correct output and outputting garbage. In programming, every little detail counts. Programmers must get in the mindset of paying extreme attention to detail. Write a function called sum. So let's do an exercise which take an integer parameter num. The sum function return the sum of the number from 1 to num. For example, if sum10 is called, then it returns 55. Now, I don't want you to use any Python built-in function. Use the accumulator. So this is, if you have not seen the accumulator before, we will talk about how to do the accumulator. I use pass, print, sum of, say 10. So let's do a simple one first. And let's run that. None is fine. I just want to see make sure no syntax error. And accumulator. In the accumulator, you will set, for example, total equal to 0. And actually, this is your accumulator. So let me put that comment over here. This is the accumulator variable. And then you have a loop for n in range from 1 to num plus 1. Num plus 1 because I want to go from 1 to num, including num. Right? So you will set up a loop. And then you will accumulate. So how does accumulator work? If you look at this carefully, how we do adding. This will be doing 1 plus 2 plus 3 plus 4 plus dot 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 plus 10, where 10 is a num. You can see that that's a repetition. What are the repetition? The addition operation. That is why I need a loop. So it basically, if I have a total set to equal to 0, the first time through, I can do 0 plus 1, which is 1. Second time, total will be 1 plus 2, which equals 3. You can see that this is my first sum, this is my second sum, and then well, it will be 1 plus 2, which is 3, right? And then total will be the next time through, 3 plus 3 is 6. So 1 plus 2 is 3, 3 plus 3 is 6, and 6 plus 4 is 10, and so forth. This operation here, this is the accumulator operation. And in programming, we can do total equal to total plus n. Accumulate the total by n. First time 2, total is 0, 0 plus 1 is 1, and then n become 2. Second time 2 will be 1 plus 2, which is 3, and then n become 3. And if you want to see how you work, let's debug this by adding a breakpoint, and I can debug this program. Alright, you can see num is 10, total is 0. Let me step into my code. Total is 0 right now. Total equal n is 1. Everybody see that? And total now become 1. N is 2. Total becomes 3. N is 3. Total becomes 6 because total plus 3, which is 3 plus 3 is 6. Now n becomes 4. And 6 plus 4, total becomes 10. N becomes 5. 10 plus 5 becomes 15. N becomes 6. 15 plus 6 is 21. N becomes 7. 21 plus 7 is 28. Take a look at this number here as I step in through. N becomes 8. 28 plus 8 is 36. And then N becomes 9. 36 plus 9 is 45. And then N becomes 10. 45 plus 10 is 55. And then the loop terminates. Oops, what do I miss? Oh, don't forget one of the pitfalls. You forget to return the data. So I want to return the total. And now I can just run this without debugging. And you can see 55. And I can make that to 100. Computer good at repeating tasks. 1 plus 2 plus 3 all the way to 100 is 50-50. How about 1,000? It's 500, 500, 50,000 and 500. 500,000 and 500, I'm sorry. And that is the accumulator pattern. Thank you.